let's look at word problems and writing equations. The first kind is slope-intercept stories. We have the starting value, which is the b. This is the point on the y-axis where it starts. It's called the y-intercept. That is the starting amount. The equation then has a slope, which is the rate. You look for the words each, or every, or per. 5 more students every 2 days. Let's take a look at this example here. She starts with 5 items. That is going to be your b value. Y equals, I'm going to put just a 5. And then she adds 20 items each day. So that's going to be plus 20, and then the each gets the variable. Now let's take a look at a system where you have to write 2 equations. So we have the first one. Class A has 10 kids. 2 more join each minute. And Class B has 5 kids. 3 more join each minute. Okay. Now here comes the question. How many minutes until they have the same number of kids? Remember, you look at the question. The question will help us make the variables. How many minutes is going to be number of minutes. And number of kids is going to be the y value. So I have my 2 variables. It's time to make the equation. The first equation, Class A has 10, just 10, so you put just a 10. And 2 more join each minute, so plus 2. But when you see the word each, you need a variable, and minutes is x. For our second equation, Class B starts with 5 kids, that's your y-intercept, and 3 more join each minute, and that's where you put the x. Both of these equations I wrote in y equals b plus mx form, but you always could do y equals mx plus b. Let's take a look at another example. Maya starts with 3 emails, and each day she gets 10 more. But Narelle started with 201 emails, and he deletes 8 each day. And here's the question. How many days until they have the same number of emails? So that's going to help me with the variables. How many days is number of days. Okay, until they have the same number of emails. And now, to make a system, you must write 2 equations. So let's take a look at this first one right here. Maya started with 3. That is the y-intercept. So y equals 3. And each day, when it says each, that's where you're going to put the variable. So each day she gets 10 more, that's plus 10 each day, and day was x. And let's write the second equation, which is going to be for Narelle. He started with 201, so that's his y-intercept. Y equals 201. And delete means minus. You take the emails and they go down. Minus 8 each day. 8 emails each day is the x. Okay? So remember, whenever it says each or every or per, okay, that is where it gets the variable. Okay, let's review the other kind of equation, which is standard form equations. Standard form stories, this is supposed to be a y. are AX plus BY equals C. So when you have these, you're going to look for two rates. A, okay, is a rate. Okay, we look for two rates. And then B, okay, B is the second rate. And C, okay, C is where we always put the total. So when we have the A, we're looking for the word each. When we have the B, we're looking for the word each, or every, or per. Here's an example. Okay. Each sandwich costs 7. And so since it says each, that's going to get the variable. And then we have each drink costing 2. Okay. Each, so we're going to have another variable there. And then the total cost was 48. So to make our equation, it's $7 each sandwich. So that's going to be 7x. Each drink costs $2. I need a different variable, y. Okay? And when you make your equation, okay, this over here is where we always put the total. So I need a total number. This was $7, and this was $2. So I need a total for the dollars, and that's 48. Let's take a look at a story with a system. Okay, the first one, kid tickets cost $3 each. Okay, here's our second thing. Adult tickets cost $8 each. Okay, you bought 10 tickets total. That's going to be a C. You spent 55 total. We seem to have two totals, which is good because when you have a system, remember, we have to write two equations. Okay, now the question says, how many of each ticket? So that's going to help me with my variables. How many? It's number of, what are the two types? Kid tickets. The first one is kid tickets, and the second kind is number of adult tickets. Okay. So let's go ahead and try to write our first equation. It says kid tickets cost $3 each kid. I need a variable, and that's going to be X. And adult tickets cost $8 each. Adults are Y. Now when I look at this, this is $3, this is $8. So I'm going to need a total for the number of dollars. Which one do I use for the dollars? And that's the 55. Let's go ahead and make the second equation. Okay, I still have this 10 number, which is a total, so I know that goes here for total, but this is the total tickets. Is this 10 kid tickets or adult tickets? And the answer is both. It's the adults plus the kids, X plus Y. Dollars plus dollars makes dollars. Here's another example. 15 friends went to dinner. Okay, that's a total number of people that went. Some people ordered pasta dish for $12. Now it doesn't say it, okay, but each pasta dish is 12. You have to pay $12 for every pasta dish. And each sandwich costs 8. It doesn't say each sandwich, but if you order multiple sandwiches, you have to pay every time. The total bill was 44. Okay, so we have another total number. How many people ordered each type? Okay, so my first variable is going to be number of people that ordered. Okay, and what are the two types? What are my two things? The first one is pasta, and the second one is the number of people sandwiches. Can't fit it. So now we're going to make our two equations, okay? A system is two equations. The first one I'll do is this money one right here, okay? $12 for each pasta. I need a variable. How many people ordered pasta? That's where I put the X. Plus, some people ordered the sandwiches. $8 for each sandwich. So that's where you put the Y. When we look at this, okay, this is $12, $8. So over here, I'm going to need a total, but for the number of dollars. So which total is it? 15 or 144? 144 is the total. Okay, now the second total number was 15 friends. That's 15 people that went to dinner. Is that 15 people that ordered pasta or ordered sandwiches? And the answer is both. It's the X, the people, plus Y, the people, for the total people. People plus people makes people. We cannot mix these totals up. Okay, let's do a couple of examples where we finish the whole problem. Let's read the story. The chess club starts with 10, and 10 new join each week. Okay, we have the each, so that's going to get the variable. And the debate club starts with 15. 5 new join each week. Okay. The question says, how many weeks until both clubs have the same number of members? So the first variable is going to be number of weeks. And the second one is going to be number of members. So let's take a look at the equation. They start with 10, okay? When it says start, that's a y-intercept. So y equals 10, okay? Plus 10 each week. I'll put the x variable there. So this equation starts at 10, goes up 10 each week, up 10 each week. When we draw our graph, we do not want any negative weeks. We start here, okay, but we can go up, up, up forever. No negatives here. When you have your variables, let's go ahead and write them right away. The x is number of weeks. And the y is the number of members. So you cannot have negative people. And this graph right here, this was for the chess club. Now let's graph the second one, the debate club. Okay, they start with 15. That's his y-intercept. And 5 new students each week. So 5 students each week is the x. When I graph this, the 15 is the y-intercept, and the slope is up 5 over 1. Up 5 over 1. Up 5 over 1. So when you graph this line, okay, you cannot have negatives, but we can keep going more members for the debate club. And then when you look right here, okay, where they have the same point in common, that is the solution. How many weeks? Okay, the answer is 1, 20. So at 1 week, okay, who has 20 members? They both have 20 members. Okay. The question said, how many weeks until they have the same number? The answer is 1 week. Okay, the last one. For the variety show, student tickets cost $4 a person. That means per. $4 per person. Adult tickets are $8 per person. $40 worth of tickets. Okay, that's a total number. And 7 people attended the show. That's another total number. Okay, I've got my information highlighted. Now let's find the variables. Find the number of students and adults. So X is going to be number of students, and Y is going to be number of adults. I'm going to label my graph right away before I forget. As soon as you know what X is, put it on the X-axis. Number of students. And Y is number of adults. Great. Now we make our system. Okay. A system of equations means 2. The first one says student tickets, $4 each student. That's 4x. And adult tickets are $8 for the adult. Adults are Y. Okay, now this is dollars, and this one is dollars. So what's the total number of dollars for this problem? $40 is how much they spent. Okay, but I have another total, which is 7 people. Are the people the students or the adults? And the answer is both. People plus people makes people. Okay, let's go ahead and graph this system. So I'm going to write the first equation right here for us. When you have standard form, you're going to find the x-intercept and the y-intercept. To find x, I cover up y. 4x equals 40, and so 10, 0 is the x-intercept. To find the y-intercept, I cover up x, I make a little y problem. Y equals 5. So the y-intercept is at 5. The x-intercept is at 10. Okay. Now remember, when you graph this, make sure your ruler is nice and straight. Get it perfect. We cannot have negative students. Okay, so since this is a real life problem, no negatives. You stop, no arrows. The second equation is x plus y equals 7. So for the x-intercept, I cover up y, and I get a 7. For the y-intercept, I cover up x, and I also get y for a 7. So this graph starts at 0, 7, goes to 7, 0, and again, do not draw arrows, okay, no negatives. This is perfect. Okay, what is the solution? The solution is the point that they share, where they intersect. This is the solution. I have the point 4, 3. Let's interpret that solution. Okay, I'm going to look at the question. Find the number of students and adults who attended the show. 4 students and 3 adults attended the show. Oops. And when you look, does that make sense? Because it said 7 people attended the show, and that does make 7 people. Great job.